I'm now going to look at metal carbonate decompositions. The general formula for a metal carbonate decomposition is as follows. We've got a metal, which I'm going to call M, and we'll have a carbonate here, and when it's heated it turns into a metal oxide plus CO2. Now, of course, what's going to happen is that the formula of the metal oxide is going to depend entirely on the charge of the metal. And you should be able to handle this for any metal from charge 1 up to charge 6. So let's take a look at how we would handle it. So looking at Na2CO3 first. It's going to split into Na and O. At the moment we don't know the charge on the metal oxide yet, and we know we're going to get CO2 as a product as well. Now, the first thing we want to do is we want to figure out what the charge on the metal is going to be. Now, if we know that carbonate has a -2 charge, what that means is if we've got two sodiums, they're each going to have a +1 charge. And the way we would do that is like this. We'd have Na and Na. This is two of them. And we know that this is totaling out to -2, which means this has to total out to +2, which means each of these has to have a +1 charge. Alright, so that means that we've got +1 and we've got -2. Now I'm going to rewrite this and show what formula the metal oxide would have. So if we've got one Na plus and an O2 minus, what we know is that we're going to need two of these to match the charge on the oxygen. So the metal oxide is going to have the formula Na2O. After that, we can then go ahead and balance it, and you can see we've got two sodiums here, two sodiums here. We've got one carbon here, and we've got one carbon here. We've got 3 oxygens, and we've got 1 plus 2 is 3 oxygens. So this one's already balanced. Alright, let's take a look at the next one. We've got CaCO3. And it's going to have, we're going to start with this one. Alright, so if we've got CO3 2 negative, that means that the calcium must have a 2 plus charge to match that. So that means that that's going to be calcium 2 plus, that's going to be O2 minus. So CaCO3 gives CaO plus CO2. And as you can see, that's already balanced as well. Alright, let's take a look at the next one. We'll go to the aluminum. Just going to get rid of this here. Alright, so aluminum, we've got CO3, 3. And again, we need to find out what the charge on the aluminum is going to be. And we've got 2 aluminums and 3 carbonates. Again, we know the charge on the carbonate is 2 negative, 2 negative, and 2 negative, which means that total charge is 6 negative. This means this has to be +6, which makes each of these 3 plus. Alright, so we know we're going to get Al and O plus CO2. O is 2 negative, aluminum is 3 plus. So we figure out what the formula will be for the metal oxide, and it's going to be Al2O3. So again, the strategy here is to make sure that we have enough of each so that the charges match. and we've got 2 aluminums, that gives us 6 plus, and 3 oxygens, that gives us 6 minus, so that matches up. Oops, that should be Al2. Alright, now we can go ahead and balance it. We've got 2 aluminums and 2 aluminums. We've got 3 carbons here and only 1 carbon here. I put a 3 in front of that. That's now going to be 6 oxygens, plus 3 is 9, 3 times 3 is 9. So that matches up for that one. Alright, let's take a look at the next one, PbCO32. Alright, same pattern. Now we need to figure out the charge on the lead. And it's going to be Pb, and we've got CO3 and CO3, that's -2 and -2. So it's going to be -4, which means that the charge on the lead must be +4. So we've got 4 plus over here and 2 minus here. So now we figure out the charge on the metal oxide. And we've got Pb, and we need 2 oxygens to match that, because we've got 2 negative on the oxygen, we've got 4 plus on the lead. We need 2 of these to balance that out, so it would be PbO2 plus CO2. And we need to balance it. We've got 2 carbons over here, only 1 here. This means that we've got a total of 6 oxygens. 2 times 2 is 4, plus 2 is 6. 2 times 3 is 6. Right, so that one is now balanced. Now let's take a look at the next couple. And we're going to look at Sb2 CO35. And it's going to split into Sb and O. We don't know the formula of that yet. And CO2. So we've got Sb2 CO35. That's 2 Sbs and 5 CO3s. -2, -2, -2, -2, -2. So that's -10, and we know there has to be +10 to match, and each of these is going to have a +5 on the charge. So that's going to be Sb plus 5, and that's going to be O2 minus. So the formula of the oxide is going to be Sb2O5, and the way I come up with that is I've got 5 times -2, that'd be -10, 2 times +5, that would be +10. So that will match up for that. So we've got 5 carbon dioxides over here, and that's 5 times 2 is 10, plus 5 is 15, 5 times 3 is 15, 2 antimony, so we're all balanced. Alright, the next one, we've got MoCO33. Alright, let's look at how we get the charge on that one. Alright, so MO, and we need 3 CO3s. -2, -2, -2, -6, and it has to be +6 to match. Alright, so that's +6, and that would be -2. So now we figure out what the formula of the oxide is, and it's going to be MO O3. We need 3 times negative 2 would be negative 6 to match the plus 6 plus CO2. We've got 3 C's over here, and that would mean we've got 9 oxygens. 2 times 3 is 6 plus 3 is 9. 1 MO, 1 MO, so we're good. So this one's balanced as well.